the end of this lesson, you should be able to find the range of a data set, calculate the standard deviation of a data set, interpret measures of dispersion, and calculate the coefficients of variation. Sometimes we want to look at a measure of dispersion or a spread of data. And the two most common measures of dispersion are the range and the standard deviation. Okay, let's find the range for a data set. For any data set, the range of the set is defined as the following. Simply take the greatest value in the set and the least value in the set and subtract them. Again, take your greatest number in your data set and your smallest number of your data set and subtract the two numbers and you have your range. So here we're given a distribution table with column A, values for column A, and values for column B. So let's find the range for each. Starting with column A, we take the greatest number in that set, and that would be 9. We take the smallest number in that set, and it happens to be 5. Subtract the two, and we have a range of 4. Now let's find the range of column B. We take the greatest value in that set, which would be 13. We take the smallest value in that set, which would be 1. 13 take away 1, which means you have a range of 12. Simple. There you have it. Standard deviation. Standard deviation is a measure of how spread out the numbers are. The bell curve below represents the normal distribution of data. IQ scores. Your IQ, which stands for intelligence quotient, is a score that determines how smart you are as compared to other people, the normal group. So by definition, the average IQ score is 100. So if you look at the bell curve, which is so commonly seen in many textbooks, you have your curve here. This is 100 is average. So anything below that would be below average, and anyone with IQ scores above 100 are considered above average. Now, 68% of the norm have an IQ score within 1 standard deviations of the average. In other words, most people will have a score within that range of either 1 standard deviation below or 1 standard deviation above the norm. So these scores are between 85 and 115. Now, the way you get the 85 here, if you see here, you have 100, 1 standard deviation from that, minus 15, that gives you 85, okay? Plus 15, that's going to give you 115, and there you have where most of the scores usually lie within that range between 85 and 115. It was said that Einstein had an IQ score of over 160. So He is one who is considered to be on the range of exceptionally gifted. The more you move past the norm of 100, the more intelligent the person is said to be. And also, the farther you are from 100, the less intelligent an individual is said to be. So where do you think you fall? Do you ever feel like this after a test? Or like this? How to calculate the standard deviation? Let a sample of n numbers, such as x sub 1, x sub 2, on to x sub n, have mean x bar. Then the sample standard deviation S of the numbers is calculated as follows. S is equal to the square root of the fraction with a numerator of the summation of the square of x minus x bar over the denominator of quantity n minus 1. Now, the individual steps involved in calculating the standard deviation are as follows. There you see step 1 through 6. You can read over them later. I'm going to go ahead and do an example to walk you through it because it will make more sense once we do an example. So step 1, find the mean of your data. So we have a data set that only includes 5 numbers, so we can easily find our mean by simply adding all 5 numbers and divide by 5. So when we do that, we get a mean of 46. Your next step is you're going to subtract that mean of 46 from each of your data values. So we're going to go ahead and do that. Subtract the mean from each data value to find what is called the deviation. So again, you're going to take the first value, 32, take away 46. 41, take away 46. 47, take away 46. 53, take away 46. 57, take away 46. Go ahead and do those calculations. Remember with the sign rules, if the signs are different, such as they're all different, one's negative and one's positive, you're going to subtract, take the sign from the larger number. So in some cases, it's going to be a positive, and in other cases, it's going to be a negative. In either case, when you add up that column, if you were to add it up, it should equal 0. Okay, so the deviation column, if you were to add it up, will always add up to 0. Okay, so let's continue the process. So we have our deviation column. Next, we are going to square that. So all of these numbers, you know whether it's a negative or positive. When you square it, it's going to produce a positive. So negative 14 squared is negative 14 times negative 14, which is going to give us positive 196. Negative 5 times negative 5 is going to give us positive 25. 1 times 1 will give us 1. 7 times 7, 49. 11 times 11, 121. Next, we want to go ahead and add up that column, because if we take a look at our standard deviation formula up top, we're trying to get our numerator number. We had our value, each value. We subtracted our mean of 46 from it. And when we got that to where it was one number, we're going to square that one number. That's our deviation. Once we square it, a square of our deviation column. The summation says, okay, all of those numbers, go ahead and add them together. So we're going to add that square of deviation column, which gives us 392. So we have 392 on top. To get our denominator, it's quantity of n minus 1. So we have a total of 5 numbers. So that's going to be 5 take away 1. 5 take away 1 gives us 4. So what you're going to have is 392 divided by 4. We're going to go ahead and do that division, top divided by the bottom, and that's going to give you 98. Notice everything is still under the radical, so now we're going to take the square root of 98, and that's going to give us approximately 9.90, and that is our standard deviation.